Hey everyone, in today's lesson we're going to talk about how to use trigonometry to solve for unknown angles. So that's a little bit different. In the previous lesson you saw how to solve for an unknown side, and so today we're going to talk about angles exclusively. Let's remember that there are three trigonometric ratios: sine, which is opposite divided by hypotenuse; cosine, which is adjacent divided by hypotenuse; and tan, which is opposite divided by adjacent. I've included two triangles here so that you can see, depending on where your angle is, how the labeling of the triangle changes. Remember, the opposite side is always opposite the angle, as we can see in both of them here. The hypotenuse is always the side that is opposite the right angle. And finally, the adjacent side is the one that's beside your angle, or it's just the one that's left over. So the question here is how to find the unknown angle. Well, we're going to follow a lot of the same steps that we did when you were looking for an unknown side. First, you're going to label all of your sides with respect to the unknown angle. So we have to write which one is opposite, which one is hypotenuse, and which one is adjacent. We then need to pick which ratio we are looking for. We need to write an equation. And then this is where it's going to get a little bit different because we are going to have to simplify our fraction and make it a decimal. And then we're going to have to use these buttons, these sine inverse, cosine inverse, and tan inverse buttons. That's what they're called, sine inverse, cosine inverse, and tan inverse buttons in order to find the angle. And so let's talk about just for a second here, what are these buttons? Well, these buttons undo sine, cosine, and tan. They are the opposite operation. It's called the inverse because it is the opposite of sine, cosine, and tan, and you'll understand why when we get to some examples, why that's important. You can try on your calculator of doing tan inverse of 0.5774, and you should get an answer of 30. So if you haven't yet, take a second to try to find them on your calculator. I've added a sample screen here of an iPhone calculator because I know a lot of you have iPhones. First things first, you need to click on the second button, and then sine, cosine, and tan are going to transform so that you can see the inverse of that function, okay? And so that's what we're going to be doing here. So you have to press the second button, and then sine, cosine, tan, and then all of a sudden you'll see those little negative ones appear right beside them, and that's when you know that you're doing the right thing. This is also just a reminder that you want to be sure you're working in degrees, okay? So if you do not get 30 as an answer, you need to click on this little RAD button at the bottom and then try again, okay? 30 degrees is the right answer, okay? Let's move on to some examples now.
Okay, let's take a look at some examples here so that we can better understand how to find an unknown angle when you are working with a right angle triangle. Let's take a look here. So we have an unknown angle and we have two sides. One is 55 and one is 34. Remember, the very first step always is to label your sides. So I'm going to start by labeling my 34 side. That is my opposite, because it is the one that is opposite my unknown angle. I'm also going to label my hypotenuse, because that is the one that is across from the right angle. And finally, the one at the bottom here is the adjacent side, because it's the one that's beside my angle. And now I need to pick which ratio I'm looking for. I have opposite and I have hypotenuse, so I'm going to write them out here. And I need to pick a ratio that has opposite and that also has hypotenuse, because those are the two pieces of information that I have. And we can see here that the one ratio that has both of them is sine. So sine is what we are going to be using. I'm going to go ahead and write sine, and I'm going to use theta to represent my unknown angle. My opposite is 34, so 34 is the numerator of my fraction, and the hypotenuse is 55. So now that we have set it all up, it is time to actually go through and find what theta is. In order to do that, I need to first make my fraction a decimal, so I'm going to type 34 divided by 55 into my calculator, and I'm going to give it about 0.62. That is not my angle. That is what sine of my angle is going to give me. I only want my angle on its own. I need to get rid of the sine. In order to get rid of sine, I need to do sine inverse. So I'm going to write this out. I need to take the sine inverse of both sides. Sine inverse of sine cancels out. It's just kind of like the way multiplication and division cancel out. Sine inverse and sine cancel out. That leaves me with theta is sine inverse of 0.62. And now here is where you are going to use your calculator. I'm going to do one with my calculator and then one with my phone. Very first, I'm checking to make sure it says degree at the top of my calculator to make sure that I'm getting the right answer. And then I'm looking for the sine inverse button, which is the tiny little orange text right above my sine button. So I need to press the second button in order to access the sine. I'm going to press second. And then I'm going to press sine, and we can see how it has sine inverse. And I'm going to type in my decimal, sine inverse of 0.62. And now you can see we have a larger number here. It actually looks like an angle. That is 38. And so we're going to round. I'm just going to say 38, or theta is about 38 degrees. Okay, awesome work. So with 38 is about what this angle is. Let's do another triangle here. I have an unknown angle. One side is 29, one side is 38. Again, first things first, you want to be labeling your triangles. So I have my opposite side here. I have my hypotenuse across from my right angle. And I have my adjacent side beside my angle. Okay, and now we need to pick which ratio is the best one. I have opposite and I have adjacent. The ratio that has both opposite and adjacent is the tangent ratio. So I'm going to start right off with saying tan of my angle is opposite over adjacent. I'm going to replace my opposite with 29 and my adjacent with 38. Okay, now I'm going to do 29 divided by 38 to get a decimal. And my decimal is about 0.76. You can usually round 2 decimal places. Now, in order to get the angle on its own, I have to do the inverse of tan. I have to do the inverse of tan to both sides. I'm going to do tan inverse of one side and tan inverse of my other side. The tan inverse cancels out, leaving me with just my unknown angle. I still have tan inverse of 0.76 on the right hand side. So now once again I'm going to go to my calculator, I press the second button, and then I press tan, which gives me tan inverse, and then I type in my decimal, 0.76. 0.76, and that gives me about 37 degrees. 37 degrees is my final answer. Okay, and our last example today, we have a triangle with one side is 56 and one side is 52. First things first, I'm going to start by labeling my triangle. This is going to be my opposite side. I have my hypotenuse here, across from my right angle, and I have my adjacent right beside my angle. It's the one that's left over. And now I need to say, okay, I need to find a ratio that has hypotenuse and that has adjacent, because those are the two pieces of information that I have. I need to pick a hypotenuse and I need to pick an adjacent. So what's that going to be? Well, that's going to be cosine. Cosine of theta is adjacent divided by hypotenuse. So let's go ahead and simplify that. Cosine of theta is 52 divided by 56. Okay, now our calculator comes in handy. We need to do, what is 52 divided by 56? It's about 0.93. 0.93. Okay? Now in order to get theta on its own, I need to do the inverse of cosine to remove the cosine. So I need to do cosine inverse of both sides. Okay, cosine inverse, cosine inverse. Cosine inverse on the left-hand side allows me to cancel out, leaving me with just theta. And then I can do cosine inverse of 0.93. I hop to my calculator here. I press the second feature button and then I press cosine, which will give me cosine inverse. And then I type in my decimal 0.93, which is equal to about 21.5. Let's round up to 22. So my final angle here, my unknown angle, is 22 degrees. Okay? So a lot of these steps are very much the same as when you are solving for an unknown side. What's different is we have now introduced this inverse that we have to take in order to get theta on its own, because remember, these decimals, these are not the measure of your angle. They're the measure of sine of your angle, which is very different. Okay? Great job, everybody.